All right, so we'll get ourselves started by mentioning that. Now, maybe before I do that, though, I want to show you how A and B fit into the proofs of these theorems. So let me just make some remarks here. So this is just a remark, but it's meant to help you to frame how these proofs worked. So first of all, I want to point out that if you take the rate of change of sine x, now let's start with cosine, because it's actually a little bit less obvious. If I take the rate of change of cosine x, so in other words, this derivative, at x equals 0, then by definition, this is a certain limit as delta x goes to 0. So which one is it? Well, I have to evaluate cosine at 0 plus delta x, but that's just delta x. And I have to subtract cosine at 0, that's the base point, but that's just 1. And then I have to divide by delta x. And lo and behold, you can see that this is exactly the limit that we had over there. This is the one that we know is 0 by what we call property A. And similarly, if I take the derivative of sine x at x equals 0, then that's going to be the limit as delta x goes to 0 of sine delta x over delta x. And that's because I should be subtracting sine of 0, but sine of 0 is 0. All right? So this is going to be 1 by our property B. And so the remark that I want to make, in addition to this, is something about the structure of these two proofs, which is the derivatives of sine and cosine at x equals 0 give all values of d by dx sine x, d by dx cosine x. So that's really what this argument is showing us, is that we just need one rate of change at one place, and then we work out all the rest of them. All right, so that's really the substance of this proof. That, of course, really then shows that it boils down to showing what this rate of change is in these two cases, and A equals. So now there's enough suspense that we want to make sure that we know that those answers are correct. All right, I think looks like the erasers are over here.